Hey everyone, this is Jacob Vollers and my partner Eric Cicero. We're doing our E&D 356 Geocoding final for section 1. I'm just going to get right into it. So as clarified in the title slide, we're covering section 1 for this assignment. We'll be referring to our study area as such for the rest of the presentation. Just to clarify though, section 1 is located what is primarily known to the local residents as the Black Rock community. This was once an independent municipality, but it is now classified as a neighborhood in the very most northwestern part of the city. As you can hopefully see here in the map, if it's not too small, I've laid out, the area stretches from right about where I-90 is located on the west there, and it stretches out eastbound all the way until we reach Elmwood Ave, which is on the east. Uh, our goal with the project is to map out pedestrian volume data throughout the section with ArcGIS software so that we can hopefully gain a better understanding of how pedestrian foot traffic flows through this section. So the main issue we ran into while trying to find information about pedestrian volumes is just really simply that there's no published data that delves into this topic matter. In order to reach a conclusion, we had to gather our own data by completing site visits and using online sources like Google Street View. Detailed below are two examples of the images we gathered from both these sources. So we have Google Street View on the left, site visit on the right. This is a panorama shot, so it is a little cut off here, but that's totally okay. So the question is then, how did we go about collecting our data? What we did is we collected 20 unique locations throughout the section and recorded how many people that we saw walk by for each location for a duration of about 10 minutes each. So shown here is a list of locations that we chose to use. Yeah, you might notice how we start at about Niagara Street and we work our way over to Elmwood Ave, as I mentioned before. You can also see various bits of miscellaneous information, such as the weather right here, and then you also have the street type here, the street name, as well as lots of other goodies. So we inputted all these addresses in ArcGIS, and then we graphed them, and we also used that to form our final comprehensive map for this project. Okay, so one thing that's really important to mention here is even though we used 20 locations throughout the project, we had to do two entirely separate surveys so that we could address both peak hour volume as well as off peak hour volume for the pedestrian flow. So what I mean by that is each address was visited twice during different days and periods of the day as well, in order to see how the time of day and the day of the week influences the volume of pedestrians that pass by. We believe that utilizing this method will give us a better overall understanding about overall pedestrian foot traffic over the course of a normal day and how it fluctuates. So one thing our group really strongly believes in is that it's critical that our data is as clear as possible. The last thing we want is for our data to be called into question due to factors that we have not thought about or listed, such as the time of the day, as well as the weather. Although seemingly trivial, these pieces of information can have a substantial impact on whether pedestrians choose to walk outside or not within our section. So in order to get the most accurate results, we felt it was best to gather data when it was sunny outside. As such, both the peak hour survey and the off-peak hour survey were both collected in sunny weather, despite being conducted on different days. The time of day can be eliminated as a variable because we have listed each survey as respectively peak or off-peak. So what exactly do I mean when I say off-peak hours, or peak hours to be exact? What that means is that the peak hour survey was conducted at a time of day where our group believed most people would be out and about walking. Thus, it was conducted when peak pedestrian volume was expected to happen. Of course, off-peak represents the opposite. So for the purpose of this project, peak hours have been designated from 4 p.m. to 7 p.m. On a Tuesday afternoon, and off-peak have been designated from 9 a.m. to 1 p.m. on a Sunday uh, morning. So we believe, going into the research, that more people would be seen walking around during the afternoon, of course. It's also important to mention how the day of the week impacted this, as more people were expected to be seen coming back from work on a Tuesday afternoon compared to a Sunday morning. I'm going to hand it over to Eric.
Hey, I'm Eric. So for our peak hour volumes, they were a little low. That you probably couldn't classify any of these areas as busy pedestrian wise. There's a few that had a good amount of people, 10 or so, but no areas where like you would constantly see a stream of people walking by. Um, but this area wasn't expected to have a high amount of pedestrian traffic in the first place. There's not a ton of stores and residential areas. There's a few, which is more on that left side of the map down there. If you see it over here, that's probably where that was where most of our foot traffic was found, and it makes sense as this area to the right of it is all residential areas, and that is mostly stores compared to the rest of the map, which like up here is a busy road where not a lot of stores, more just offices and stuff were. So it expected to be less pedestrian foot traffic over there. Um, so yeah, like I said, the high was on Niagara Street, a lot of restaurants over there. The average given by ArcGIS for this time was 5.5 out of all the locations that we studied. Moving on to off-peak hours. All the spots are a little lower. There's one or two that are about the same, or even one that has like one more person. Makes sense because who's going to be walking around on a Sunday morning compared to after work? Maybe they're grabbing food on during peak hours, but right now no one's going to be grabbing food at 9 a.m. really, especially since most places that we studied were like delis and not like breakfast places. Um, uh, more locations were closed obviously on a Sunday morning compared to a weekday afternoon. There's an average of 4 for all these locations, but the pattern stayed relatively consistent between the two, just less during off peak. All these were made by assigning a pedestrian count value in the attribute table of each point and then displaying it through bar graphs, as we felt that would be the best way to display this data. It's a relatively bold way to show it. It's not like hard to miss, not easy to miss, as like just different colors would be for different values. It pretty evidently shows where the most amount of people are walking. So moving on to the comparison between the street-based and parcel-based geocoding results. They both are relatively accurate and they both do show more or less same spots. There is about one inaccuracy in that these spots right over here have the address listed wrong on Google, so therefore they were geocoded wrong. They're about a street over up here, but that's about the only inaccuracy between the two. Street-based is a little bit more inaccurate due to just how it's geolocated. It doesn't look at numbers, just goes by streets and segments. So it places itself in the middle of its segment that it's actually on. So it's a little further away from the actual location than many of these other stores are. Meanwhile, the parcels are a little bit better due to the fact that they're using census data for parcels of Buffalo. So they actually look at the address and place it proportionally in the parcel based on what their address number is from each end. So they're closer to the actual locations. Yeah, okay. So then Google Street View versus Fieldwork. These ones are about the same as the other two. It's almost like a combination of both where you're looking at the street again, but these ones were, the Google Street View were hand chosen, so they're a lot more accurate. As you can see that this spot one over here is actually in the right spot. The Google Street View pedestrian counts are much lower than our fieldwork, but that also makes sense due to the fact that when Google Street View makes their images, it's just a car driving by for a few seconds at a time. So if there happens to be a pedestrian in the picture, okay, someone's in the picture and that's like one person. But we were out there for 10 minutes, so like our counts are much higher because we saw many people walking by compared to just the one person who happened to be caught on camera by Google. Yeah. So that's that. How do our findings hold up? We felt that they made sense, all things considered. The higher places were restaurants, the smaller places were things like convenience stores where you were more likely to drive to. They were on busy roads where there were sidewalks, but they were less used. The off-peak and peak made sense. There was not like a huge difference between the two. There's not more people during off-peak hours. Also made sense, all things considering, that this area is not doesn't seem like it would have a high pedestrian count in the first place. Plus, it's getting to the winter, so less people are going to be walking around as it gets colder, and COVID's still going on, so more people are less likely to leave their houses if they don't want to come into contact with other people. So pedestrian counts will go down for all those factors. Yeah, so we thought it was a decent representation of the area, and yeah. So for the conclusion, we felt that ArcGIS was a convenient way of gathering, analyzing, and presenting this data that we were looking at, or anything that would be having to do with a geographic location. We felt that the walkability of an area was sufficiently determined. Um, it was limited, our study was limited by the fact that we only gathered data twice during 2 days, 2 different conditions, and we were only there for 10 minutes. So like, to improve the study, we could be out there for hours at a time gathering data. We could go during different weather patterns, different seasons, even different years, just to compare all the data between those and see how it all affects walkability and see like what the average walkability of this area would be.